Hey, what's up everybody? Mark Price here at devslopes.com, and we've been building a really cool game so far. We've got environment set up, we've got textures unlit, which I think looks really nice, and we kind of built our first little moving platform. And so in this video, I actually want to get the moving platform moving, and we'll write our first script, and it'll be great. So let's go ahead and do that now. Let's get our script and our platform moving. So prior to writing the script, it probably makes sense at this point to put this object in a prefab. Okay, and what a prefab is a reusable or recreatable object that you can instantiate or otherwise use and duplicate, meaning you can create something and bundle it and then drag and drop it in anytime, kind of like a bunch of presets. And so what I'm going to do here is I'm going to, in the assets folder, right click and go to create new folder, and we are going to call this one prefabs. Okay, and inside the prefabs folder, it's empty right here. So what we're going to do is we're going to take this platform, okay, and then we are just going to drag it here into the prefabs folder. Okay, and so now rather than just duplicating this right here, in this or any project, you can just simply drag a prefab to create a new one like that. And whatever changes you make at the entire prefab level will be applied to all prefabs, which is really cool instantaneously. So if you had like 100 prefabs of, let's say, these platforms, and you changed, you wanted to add a script, well, you don't have to go and manually add it to all of the prefabs. It'll update automatically, which is really nice. So we got our prefab here, and let's create our very first script. So in the assets folder, I'm going to right click, go to create folder, and we're going to call this scripts. Okay, and in the scripts folder, we're going to right click and go to create new C# script, and we're going to call this one object, like a movable object. Okay, and what we're going to do is we are going to double click this script, and there we have it. Okay, this is looking real good. Let's make this bigger for you here. I'm going to hold down Alt and then scroll in to make the text much larger. Okay, so what do we want to do? So what we want to do is we want this platform to start moving from the right-hand side to the left-hand side. And then when it hits a certain point on the left-hand side, we want it to move back to the right-hand side. So it has this effect of moving ground that never ends. And the reason why you wouldn't just keep creating new objects every time is because you would start getting a lot of objects built up in memory. And we're just going to reuse a few of them, maybe 3 or 4, until it looks like an infinite looping ground, which is exactly what we want. So first things first is, how do we move something? Okay, well, we know that the update function right here, okay, is called once per frame, okay, which means that this is where things are going to get moved. Depending on the frame rate of your game, it's just called multiple times a second, okay? And so this is obviously where you want to start moving things. It's very similar to the original motion pictures when they first started making movies, right? It was just a bunch of snapshots, okay, put all together to create the essence of life, of movement. And so that's kind of what the update function is like. You move something a tiny bit every single frame, and then it gives the appearance of smooth flowing movement. And that's how games work. They always have some type of update or a loop that's called over and over and over again. And every script that you write in Unity will have an update function and a start function, and this will be called X amount of times per second, okay? And it's common to see that number around 60 frames a second. It depends again on the platform, etc. So update, what do we want to do here? Well, we want to move it a little bit to the left each time. And how do we do that? Well, our Unity objects, this platform for instance, let's select it here. If you notice that it has a component on it, and the component that it has is a transform, okay? That's the position. And we can actually access this right here via code, okay? So I think that's what we want to use to move our platformers. We want to use the transformed components to move it slightly. And this is how we're going to do it. We're going to say transform, okay? Notice how I put a capital T there. I'm using the bare bones raw mono develop, which is not very user friendly. And it does stupid things like capitalize this when I don't want it to be. So transform with a lowercase dot translate with a capital T. All right. And we're going to say vector3 dot left, and we're going to multiply it times, and do some order of operations here. And let's just put a number in here. We're going to say 20 times time dot delta time. Okay. Let's talk about this now. Okay. So what is happening here? So what's happening here is every time a update is called, it's going to translate, which means move. Okay. And we're moving on the vector3.left position. So we're translating it by the x coordinate, right, from left to right, and then of course to the left. We're not translating it, you know, with depth in the z or up and down. We're moving it to the left. So we're calling transform.translate. So we're saying move the transform of this object. So anything that's attached to this game object is now going to move. We're accessing the transform. Now this is not going to work unless this game script object is actually dragged onto the object, which we haven't done yet. But we're assuming it's there. Okay, and it knows this keyword here, transform. It's grabbing it for us when we type it in. And translate is also an official function, and we're moving it to vector3.left, which is another official Unity 3D function, okay? This, and this has nothing to do with C# and is all Unity 3D built-in functions. So we're saying move it to the left, vector3.left, okay? And then we're going to multiply it. And right now I just picked an arbitrary number, 20 times time.delta time. So we're saying let's move it by a certain speed times time.delta time. And what is time.delta time? Oh my gosh, this is just weird. I'm going to quit. Game development is too hard. No, just never fear. I'm here to help you. So time.delta time. So one of the problems when you're building a game is that computers have different frame rates or they have different graphics cards and different processing power. So my point is, let's say you're playing this game on an iPhone 4, okay? And another person's playing it on an iPhone 7. All right. So the iPhone 7 is very, very powerful. Much more powerful than the iPhone 4, probably like 5 times more, if not even more than that. It's grown quite a bit. And so what's going to happen is your game's going to run faster and be able to run more frame rates. So if you had both those devices, one in your left hand, one in your right hand, and you were watching them, the one in the left hand is going to appear to move slower, and the one on the right hand is going to appear to move faster if we did not have time.delta time. If we were just moving it by some number, okay, then it would one would move faster than the other. That's not really fair, right? In fact, that's how hacks and cheats are done. Because if you have if you're playing a multiplayer game, for instance, think about this on a console game. Okay, if you've got a game, multiplayer like Call of Duty, all right, and let's say you're playing on PC, one person's game engine is rendering it a lot slower than the others because the processing power, right? Is it going to be fair that the person with the more powerful computer gets better kills and things like that because their computer's faster? It would not be fair. It would cause lots of problems. So games are built with some type of delta time. And delta time is the time it took to complete the last frame. Okay, so it's like normalized. It balances it out across the frame rate to make it equal for all devices. So and it also makes it a little bit smoother. And you're going to want to get in the habit of looking up Unity documentation. So we're just going to type in Unity and delta time, and we're going to go over here and look at the documentation just so you can get in the habit of doing that. You should be living, loving, and breathing this Unity documentation. And here's the description: the time in seconds it took to complete the last frame. Use this function to make your game frame rate independent. Okay, that's kind of what I just explained, right? Frame rate independent. If it's not frame rate independent, some games are going to run faster than others, and that you can never do that in a multiplayer game. That's just terrible. So that's what's happening here. We're just calculating the time it took to perform the last frame times some arbitrary number to see what happens. And this is going to happen every single time. Okay, so we've talked a lot. Let's see what actually happens. So let's go back to our game, and we're going to take this script here called object, and I want to drag it on to my platform here. Okay, so drag it on here, and what I would anticipate happens is when I start the game, in fact, let's move this platform a little bit over here. When I start the game, this should just start moving to the left if everything worked as expected. So let's go ahead and see. Press play. Okay, it's moving really fast, and there it goes off the screen. So it definitely worked, though. So congratulations on creating some logic for our game here. This is the beginnings of a lot of cool stuff that you're going to be doing. So we just moved it. It's really, really, really fast. Also, I don't like hard coding this number in here. So we're going to do something else. We are going to put in what's called a serialized field. okay? And we're gonna make this a float, and we're gonna call this object speed. And we'll give it a default value of 1. Okay, this is really cool. And then what we're gonna do is we're gonna change the, instead of 20, we're gonna change this to object speed. Cool. Again, our monodevelop is not very smart, not giving us autocomplete. It's really a pretty trashy system. And what's actually interesting is in previous versions of Unity, it was a lot better, and things have just gotten worse. But we'll fix that later on. We're just doing bare bones right now, so it's good to get the hang of things first. So what we've done is we've just said, instead of doing it by 20, let's do it off this variable called object speed, and we put this serialized field in front of it over here. Okay, and so let's go back to our code and let it load for a second here, and notice how this just popped up on our platform. Platform is selected. Now there's an object speed. This is one of the most beautiful things about Unity. You can't do anything remotely like this with SpriteKit or other platforms, but in Unity you can. And you can change the value of things right here from the editor. So if I press play, I know that 1 is too slow. So I press the pause button. Well, now guess what? What if I change this to 10? Okay, change the object speed while it's in pause mode, then I unpause. How cool is that? We just changed something real time by making a serializable field. And that's how you start testing your game and making it perfect. Don't start coding things in. Put it here in your inspector, okay? Write the code as you normally would, like this, with a variable called serialized field, and make it accessible to your game designers if you have one. So rather than you trying things out and your game designer's like, why don't you try 12 or 15? You can let them do it themselves. Or of course, if you're an indie developer, it makes it easier for you. And then they can go in the game and actually adjust it. And all this information saves. So long as it's not in the play mode, which it is right now. 10 is still too fast. So I'm gonna try 4 and unpause it. And 4 looks really nice. So I'm gonna unplay the game, and notice how the platform is set back to 1. Because when you're in play mode, nothing saves. This is a common rookie mistake, okay? Is changing stuff when you're in play mode. It doesn't save. It's just so you can test things out. You got to remember what happened, or take screenshots or things like that if you're messing with variables and numbers here. So object speed, with the game mode off, we're not in play mode anymore. We're going to press 4 and save it like so. Okay? And now if we run it, very nice. Okay, it is doing exactly what we want it to do, and it's moving across the screen. We have actual game action going on here. Now, the next thing we want to do is we want a few more platforms, because obviously we don't want to see empty space. And then when it gets to a certain point on the left-hand side, we want to reset it to wherever it's supposed to go. And we'll figure that out right now. So what I'm going to do is make sure that this is, move it to the left, so make sure that we don't have any empty space. You know, we want to make it look like it's the real deal. Okay, and I'm always doing Command S or Control S to save the game as I'm going along and editing things, which you want to make sure that you do as well. And so what I'm going to do is I'm going to go ahead and Command D this platform, all right? And we're going to move it over here and just kind of eyeball it. And if you're wondering why I didn't just drag the prefab on again, it's because this is already in the position that I want, and it's already linked. Notice how it's blue. These ones are not blue, they're like they're dark gray, but this one's blue, and that means it's linked to a prefab, which is exactly what we want. So I'm just going to adjust this till it looks about right. Okay, and this is looking good. And maybe we'll do 3 platforms. We'll see. So I know we'll do it 3 at least. 4 is what I meant to say. Maybe we'll do 4. Maybe we won't. Maybe I'll fight them, maybe I won't, you know. Here we go. Right about there. That's looking real nice. Okay, so the idea is when this gets to a certain point where it's no longer showing on the screen, I want to reset it. I want to move it back to some position, okay? And so let's take a look here. So let's go to platform 1, and let's just move it until it's off the screen. And again, we're eyeballing this. We could have done it programmatically, all with mathematics, but this is just as easy. And there's nothing wrong with doing it this way. So let's go ahead and just move it over to the left. And when it gets just barely off the screen, maybe like right there, I want it to disappear and restart. So let's go look at this position. This is negative 21.65. So I'm going to copy that number here. Okay. And then what I'm going to do is I'm going to undo this movement, go back to my code, And what we're going to do is we're going to create a starting position. So we're going to say private float, and excuse me, not starting position. This would be the reset position. And we'll just paste that number in here. So basically, whenever it gets less than or equal to this reset position, we're going to move it to the right-hand side. Okay, and that makes sense. It makes sense to me, at least. And the reason why we're making it private is because if we make it public here, but if we put this on here without the, in fact, the serialized field should say private as well too. If we make it public, then it exposes that in Unity, so you can change the variables just like the serialized field does, but it also makes it public so other classes can come in and objects and manipulate it, which is not what we want. You always want to make your variables private. Always, always, always. Okay, this is called data encapsulation, a super important programming principle that does not just apply to Unity, but applies to all programming languages, or at least most of them. Okay, so reset position. When it gets there, we want to reset it. Okay, that's what we know we want to do. Okay, so let's write the code for that, and we lost our code here. Let's write the code for this and see what happens. So we're going to move it. We're in the update function, right? So if transform.local position, okay, local position is the local position of the object. There's global position and local position, and you'll learn more about it as you experiment more with Unity. But we're going to move the local position of the object, okay, we're going to check the local position of an object. So local position.x, and by the way, local position is what's being manipulated with that vector3.left you see there. So if transform.localPosition.x, remember we're moving from left to right, and if it was up and down it would be .y, is less than or equal to reset position, what do we want to do? Well, wrong side. Okay, what do we want to do? Well, we want to move it we want to move it somewhere, right? Where do we want to move it? That's actually that's the real question. Where do we want to move it? We want to move it back in front of the other objects. So I think what we should do is we should put some arbitrary number in here, okay? And then move it there and then see how close it is to where we want it to be. And I'll show you what I mean here. So we're going to move it to a new position, vector3. We're creating a new variable called vector3. Okay, it's a Unity 3D class. Vector3 has an x, y, and z position. Equals new vector3, and we're going to pass in some arbitrary number. Let's say 120. Okay, and we're going to say transform. Oh, no capital T. Thank you. Dot position. Dot y and transform. Press escape. Dot position. Dot z. Okay, so what we're saying here is we just want to keep the existing y position and the existing z position by calling transform.position.y. If we change those, then it would move our object, which we don't want. We only want to manipulate the x-axis, and then we'll actually set the position on the transform. So transform.position equals new position. So what's happening here is we're just saying, hey, when we get past the reset position, okay, let's just move it to the right-hand side somewhere. And I picked 120, arbitrary number. It's a positive number. It's on the right-hand side. I want to move it over there somewhere. And it makes sense to me. So, cool. Let's just play around with it and see what happens. The moment we see something reset, I'm going to pause it. Okay. I just paused it. It's way over here, way too far. Look at all this space here. But what I'm going to do is I'm just going to go in here and move it over while I'm in play mode. And just until I can get it lined up. And we'll see if we can just move it on here like so. And then that's the position that's the real position. So this 79.67. Let's see if it works. So let's go back to our code. And we're just going to say 79.67F. That's where we want it to move to every single time. And let's go ahead and see if it's working as we want it to. Okay. It's looking good so far. Boom. Right there. Okay. Let's see if it does it again on the next one. Boom. Did it again. Looks like it's working pretty good. Looks good over here too. Pretty crazy, huh? Video game magic. The things that you don't think about when you're playing a game. Like, you're probably thinking, oh, there's an infinite, maybe a level designer designed all these platforms or whatever, and there's an infinite amount of them. But who knew that we only had 3, and that they're just moving position every single time. And we just eyeballed this. And the reason why we eyeballed it is because it's a little bit hard to be mathematical on this. And maybe you're thinking, well, what do you mean? Well, okay, this object right here, it does have a width. And so does this one, and so does this one. And so we could have gotten the renderer and calculated the width of all 3 of these and said, oh, this is the object width, and you multiply the object width on times as many platforms as we have, so 3, and it would have done it mathematically and perfectly. The problem is, okay, because the way the assets are designed, we have them overlapping, as you can see right here, okay? And so the problem is, this overlapping width is going to take away from the proper size. We wouldn't get an accurate size mathematically because we're overlapping things. They're not flush to the edges. And so we'd start getting spaces and all kinds of other problems. And so it just made more sense to hard code the position in, and that's completely fine. Why is it fine? Because this is a game that's going to repeat itself over and over and do the exact same thing every single time. Okay, so it makes sense. So that's it, really. Look how easy it is. Like, we have a moving platform. If you can imagine our little character, he's like flying like a little flappy bird. There's obstacles, and you know, he just keeps going and going and going, and really cool stuff. So we've got that working. Let's make sure we save the scene. Our code is fairly simple. Okay, we're just updating and moving it here. And if the current position is less than or equal to the position where we want to reset, which you saw me do, we just picked a spot. Then let's go ahead and move it to a new position. I put in an arbitrary number at first, and then as soon as it happened, I paused it. I know it's not an exact science, but it worked, right? And then we just moved it to about where we want it to be, and it looked good. And video games are all about, video games are not about being mathematically perfect. They're about having fun and looking good, and it looks good. And so we move it to that position, and that's all that's happening here. And this one script object is on every one of these because we made it a prefab, as you can see. So there's the script object on each one. If we were to change the object speed on any one of these here, it would break because one would be going faster than the other. So that's it for now. This is really cool stuff. We're making great progress, and our game is really coming together. Take that, stupid Flappy Bird. We got the coolest thing ever here. Mark Price at devslopes.com. Moving on and forward.